So Milton, have you got my content up?
Okay, I can see your content.
You can see it? Great. Okay, so I mean the whole point here is what we want to avoid is things that look like this, right? I mean, we've got 50% of the stuff here is commented out. There's no function we can reuse. There's a lot of hard coding. We need to go through and really it's not very self-explanatory, right? And this is something that I'm sure myself included, we have lots and lots of these little snippets lying around. You don't use it for a while, and you almost have to go through and rewrite it from scratch because you've forgotten what all of this stuff means, right? So just quickly recapping, some of the main topics. When you're thinking about your code, when you're thinking about writing something in PowerShell, or you're revisiting code that you already have, right? We really want to be able to understand what it's doing. You've got to think of it like a story. It should be self-explanatory, right? So if you need to use comments, it means your code isn't clear enough, right? You need to think about how to rewrite it in a way that as you're reading the code, it's telling you what it's doing, right? It's always making sense, and you don't need to write comments behind it. And try to leave your code cleaner than you found it each time. So every time you open up that script, try to make a little improvement. You don't have to make it perfect the first time round, but every time you open it up, every time you touch it, try and think about ways that you can leave it a little bit better. And that's how you end up with great script libraries. And I think this really comes down to getting it working is very different from completing the task, right? Often we're researching different commandlets, different parameters, trying to work out how to get that exact output or that exact outcome. And as you're going through that discovery process and investigation process, you do end up, getting a little sidetracked or ending up with some things that don't make sense straight away because you don't really know where you're going to end up. And that's fine. That's how we learn new things. That's how we get new functionality. But once you've got it working, that doesn't mean you're done, right? You need to keep going through it. So simple things matter, right? Good variable names, right? Distinct function names so that it's clear about what each of them doing. Readability is really important. One of that code snippet we saw at the beginning, there's a lot of aliases and things that get really cool one-liners, and PowerShell used to be all about this cool piped one-liner, but that's it's a nightmare to go through someone else's code, but even a nightmare to go through your own code even a short time later and really work out what's happening there. So really focus on readability and understanding your code. Anytime you're repeating the same code, that's a candidate for a function, right? Take it out in its own function, and every time you need to use it, call that function. Don't have that code repeated over and over. So that's a really easy way to identify function candidates. Again, a function should only ever do one thing, right? And make sure that you're building functions and modules that are reusable, and then you call those functions inside scripts that are for one-off combinations of tasks or to apply those functions, but you need to have those modules in the back end that can be reused over and over again. Otherwise, you're going to find yourself, solving the same problems multiple times. And as you make an improvement in a module, that improvement will flow through to all of your scripts. But if you've done each script independently, you need to go through one by one and make those same improvements all over your library. And again, do it again and again and again. Every time you use it, every time you open it up, if things aren't quite right or you can tweak something and make it a little bit better, we need to keep iterating over, right? So to just very quickly recap some of the things we're going to talk about today and what we covered last time. Iterate, right? You don't have to get there in the first go. It doesn't have to be perfect first time. And to be honest, it's impossible to get it perfect first time because you can't predict everything that's going to come out of the script when you first start solving a problem. So just keep going over and over and over again, keep reading through it, keep working on it over time, and you'll end up with some really nice, really elegant solutions. Look for any repetition that you can pull out into a function. Look for multiple levels of abstraction. This one I think is not intuitive what that means, but I'm going to show you some code very shortly that will explain what that means. But we want to make sure that when we're in a function, we're not, we don't have some commandlet calls, then we've got some .NET calls, then we're, looking up some object, parameters, and we're jumping in and out of different levels of information. Right? Some's very low level, very detailed, some very high level commandlet. We want each of our functions and areas to be at the same level. So if we're calling functions, make sure we're calling functions for everything that we're doing in there, sub-functions. If we're looking at detailed object information, keep that separated somehow so that's all happening in one clear spot. Look for related tasks. Look for tasks that are very similar that maybe we can standardize. Maybe we can sacrifice a little bit of customization to get a new function there that can be repeated. If we just give up a little bit of, specifics that don't really matter. And definitely use tests. Last time we used Pesta, which is a great testing suite for PowerShell, and use source control. So you can make sure you can make changes and run your tests and you make sure you didn't break anything, right? That's how you get the confidence to make changes. And source control gives you the confidence as well, because if you do break something, you can easily roll back, right? Or you can split out a branch, you can mess around with it. If it doesn't work, you can just get rid of it. Once you get it working, you can merge it back in. So those tools of testing suites and source control are a really important part of this process to give you that control. We're not going to look into them today as much as we did last time, but you'll see a little bit, particularly of source control, as I go through different iterations of the code today. So last time we looked at a system information report. I just pulled this script off the PowerShell script repository, right? We went from a single script file to 3 modules and 3 Pesta test files, one for each module. We went from 57 lines of code, of which about half were comments, to over 330 lines, right? A lot of which is white space for formatting and readability. We went from a single function to 10, but it's easier to read. It's easier to reuse, and we'll see even some of those functions from my last presentation I've reused in this script today. And it's much, much easier to support. It's easier to understand and reuse, so when problems occur, it's easier to isolate where they are and correct them. And not only that, but it's much, much faster. Okay, so short aliases and undescriptive functions do not translate into speed when the code is executed, right? All it means is you've got a pile of stuff that you can't understand and that you can't modify. So when we took the final output after all of those iterations and improvements, we ended up with approximately 40% reduction in runtime. Okay, now if you do that over all of your code, all of the time, that's a really vast improvement. And some of you might be managing relatively small groups of machines, but I know a lot of the guys in the PowerShell group in Singapore, they're running scripts against tens of thousands of objects or even hundreds of thousands of objects. Right? It doesn't just need to be machines. You might be managing 200 machines, but if you're doing something against Active Directory objects, for example, even for 200 machines and 200 users, you might have 10,000 objects. Right? We're talking about almost cutting the time to run your code in half, right? Just through restructuring it. We didn't make any functional changes last time. All we did was restructure the same code. So if we have a quick look at that, jump out here, I can show you what we did last time. We started with something that looked like this: get sysinfo, right? And actually this original script didn't have a function at all. It was just a script, and I wrapped a function around it so that we could do things like measure command. Right? We've got all kinds of, we've got HTML mixed in here, mixed in with PowerShell. We've got lots and lots of repeated calls to get WMI object, right? We can't even fit everything in the screen, right? We've got hard-coded text strings in here. Keep writing to file path over and over again. We've got lots and lots of writes. Almost every line we're hitting the disk, which is where most of that runtime is, right? All kinds of problems here in working out what's going on, in reusing this, right? And what we ended up with was a nice simple function like this, right? System information equals select system information from target system. Report template comes from get report template, right? And this is where the level of abstraction comes in, right? Style equals get HTML style. We don't write the HTML code in here, right? We squirrel that away where it, can be contained, and it is a bit messy. It's not nice, so let's hide that away somewhere. Let's have nice, simple function names where we can understand what's happening, right? And all this does is build that report. Okay? It doesn't understand anything about getting the system information. That's all headed in select system information down here, right? And even this doesn't understand anything about WMI. Right, it calls specific functions that understand what the WMI filters are and how to make those calls. So this is a really important concept, and it's something Paul brought up when we were just chatting at the start of the session, that PowerShell is moving towards being a general programming language, right? And we have to start thinking about how to develop programs as opposed to just, functional scripts. We need to go beyond just getting it working and start making proper solutions to problems that we can reuse over and over again. Right, so today we're going to do a similar exercise, a little bit different. Last time what we did is we didn't change any of the functionality of the script. We essentially just reorganized it, and that was to demonstrate that just having the right structure and organization can make a huge difference in your code. We're going to do something a little bit different today and actually just take another solution. So this came from the script repository again. We're going to take a solution to a problem, and we're going to build the same functionality, but we're going to build it from scratch by rethinking some of the decisions and rethinking some of the ideas. So this script here, the point of this script is to take a group of URLs and check them, right? Make sure that they respond, right? So you might be monitoring your CRM web application, you might be monitoring Google for some reason, right? It doesn't matter. Essentially, we're going to check a web request and make sure that it comes back. And there's also some functionality in there to check that the page that comes back is the right page. It has certain keywords in it. We can also write it to a log file, and we can send an email alert if we find that it fails, right? So just quickly looking at this original script, the whole first page and down some, basically until here, until line 34, the first 34 lines are a whole bunch of mess, to be honest. Basically trying to resolve issues with the getDate module, right? First of all, you can see that we have a big comment here saying the below code is because of this bug, and then we have it repeated here, the above code is because of the same bug. So we've even got duplication in the comments, and to be honest, if getDate was that buggy, I'd probably find another way to get that information, right? I think, or squirrel this away in another function module somewhere, and just have one line there that iterates through and fixes the bug for you before you start. We've got some transcript stuff here, which I couldn't get working. My machine kept saying it doesn't support transcript. I'm not sure if that's something legacy. I didn't really worry about it too much. We're importing another module to handle an ini file, which is where they are storing the URLs to be checked. I don't really like that either. I don't like mixing different formats. Ini files are great, they have their place, but if we want to store essentially what are variables, this whole module is to take a PS object and write it to an ini file, and then read an ini file and convert it to PS objects. Why don't we just save the PS objects directly in a module, in an array ready to go, right? And then we keep everything in PowerShell. We don't have to resort to these unnecessary dependencies, right? So basically, if you can't get this to work, then this whole thing's going to fall apart, and we're switching between different formats, which isn't really, I don't think that's really necessary. We're not really getting a lot of functionality there. Again, I've got a bunch of static variables, which would be great parameters if this was a function. We're also doing a lot of different things in here, right? We're writing transcripts, we're reading files, we're sending emails. All of these are separated things, and we're going to send an email. It'd be great to have a single email module where all my other scripts could send emails as well, and I don't have to write this over again. All right. And then we're going to iterate through each of our requests. Here again, so this is about different levels of abstraction. Okay. Here I'm accessing this object. I'm using some commandlets. I'm accessing .NET objects, all in the same area, right? And as we read through this, we really need to stop and pause and work out what's going on, right? And why are we calling init key over and over again, right? We've got to keep looking all the way to the end to see what's going on, right? And finally, we invoke our web request, right? Somewhere in here, we're catching some errors, right? This bit, I don't really understand this at all. We're calling the last error exception, and we're writing it out to this file. In the next line, we're reading the content of that file, and then we're deleting that file. I'm not really sure why we didn't just put the output of this into this variable straight away, right? So that looks like they've kind of made changes over time and got a little bit lost, right? And they're essentially, this line and this line are just canceling each other out. And there's a whole lot of writing to a file, reading from a file, deleting from a file that just doesn't make sense. Again, we've got quite a bit of hard coding of, different object parameters, right? And then we've got a whole mess here to send an email, right? That is a nightmare to understand. What actually are we writing to the email? What does it look like? What are we doing here, basically, right? What is it that we're creating? And then we've got the same mess being written out to a log file, right? And then somewhere down here we're deleting older log files. Okay. This is the one bit actually I didn't get time to build in the functionality of going through and cleaning logs. But again, this kind of thing, like cleaning up files of a particular age, these are all great script candidates. Sending an email, let's make this a script module that we can call over and over again, right? Even writing to a log file, if we wanted to have a standard logging format, right? If we wanted to come up with something that's standardized across all our scripts, that's a great candidate for a scripting module. So rather than go through and do the same restructuring on this and the reorganization, what I've done is essentially looked at the functionality and said, okay, how could we solve this same problem, but in a cleaner, more elegant way, right? So let's just start really basic, right? What do we want to do? We want to check a particular URL, okay? So, and this is what I'm talking about, iteration, right? We don't have to get the whole solution from the start, and we don't have to know exactly what we're doing from the very beginning. So let's just try and invoke a web request, check what the status code is, right? Print that out, and if something goes wrong, let's catch the error, right? I mean, that's as simple as it gets. Okay, so then obviously we need to get a bit more sophisticated to get all the way through, but you can start with very simple solutions like this and then work in more and more functionality. So let's see how that evolves. And this is where our source control is important. So right now we're at the initial commit. Just a really basic idea. Go work out how to make a web request. Work out, what do we need to check? What is this called? It's called status code. I only know that because I tried it and saw what happened, right? You can't know that from the very beginning. Even you'll see later that .exception doesn't get me what I want. I need to use .exception.message to get what I want. Otherwise I get an exception object and I don't get the output I want. All of these things will come over time, right? So source control is really important to work through those different steps. So let's just update to something slightly more sophisticated here. Okay, so first of all, let's try and get rid of some of the hard coding of different object types and get a clearer level of abstraction and a nice result that we can bring back. So here already we've created a custom object, right, called result. So once we check the URL, we're going to end up with a nice PS object that we can then push down the pipeline, do all kinds of things with, right, rather than just text on the screen. We're going to invoke a web request, right, and then we're going to start abstracting different levels. So instead of understanding what request looks like, instead of understanding that the request has a status code, right, we've moved that into a function to get the status code. We just pass it the request, and it'll populate the response code field of our result object. So in the future, let's say that the invoke web request starts returning a different object. Let's say that they change the format in that commandlet. I don't have to go rewrite my check URL function, right? I've got a get URL response code down here, okay, that understands that. I can change that here. Let's say they start calling it response code instead of status code. Okay, and let's say I've got a script library that does this all over the place, calls check URL, but I've got other functions using it. Just by updating that, I can correct all of those lines of code, right? Also, I can understand very clearly what I'm doing because I've got nice verb and noun things. I'm invoking a web request. I'm getting the URL response code. I'm getting the URL message, right? And if that fails, okay, I'm setting the response code to NA, and I'm getting the last error exception, right? This is easy to read and understand. What does check URL do? It's much easier than trying to understand what each of these objects are and how they work, right? What is status description? How do I get the last error exception, right? I don't know, but I know that this function is returning it. I don't need to know that it's error object 0.exception.message, right? I can still understand what check URL does. So this is where the level of abstraction comes in and the readability of code. Okay, but there's still a lot of functionality missing, right? We've got a couple of basic supporting functions here. So let's look as this progresses and we try to get into more detail. So here we're moving up. You can see here we're slowly moving up this chain of commits. So now we're adding a content check. Right? We want to be able to check a string exists in the page. Okay, so now check URL. It's got another parameter here called check string, right, where we can provide a string, optionally to check. We've still got our result object. Okay, but now we've got our check string and our check string result members. Okay. We're going to try the same invocation of a request, get the response code, get the message, right? And if our check string's not null, we're going to send that and populate that result via check URL content, right? Again, we've put that into a function. We haven't put in the pattern matching in check URL. Check URL shouldn't know about that, right? It's a different level of abstraction. So we just send our request object that got returned and our check string, and we let check URL do it, okay? And that's down here. So check URL knows how to call request.content, do a match against the string, and return a result, right? If it works, we get one message. If it doesn't, we get another, right? So we move all of this essentially messy stuff, all of these details, these messy details, we move them as far away as we can from our primary functions, right? And then again, we've got our catch if something goes wrong. So you can see, as we add different capabilities, if we have a good structure to start with, we can add more and more functionality over time, right? But our code still, you know, this check URL hasn't expanded much, right? It still fits within 24 lines of code, right? And actually the real functions, other than this, you know, the parameters and the sort of formatting around it, you know, fits in less than 20 lines of code. Okay, this is still easy to understand. We're not getting caught up in lots and lots of details. And we don't really have to remember what check URL content does. We don't have to remember about, you know, we've got to call the .content member of request, you know, is it CMatch or contains, or, you know, what's the right check to do? I solved that problem down in here, and now I can forget about it, right? And if I need to do a similar thing later, you know, this might even be a better name for this, might be check content match, right? It doesn't have to be URL content. All I'm saying is I'm giving a particular object, and rather than calling .content, maybe I should be passing strings straight into this and doing general matching that I can reuse later. That might be something to revisit. Okay. So again, let's keep moving along. Let's add support for credentials. There was support for credentials in the original, right? And that's true. Some of our websites and web applications might require some kind of authentication. So let's look at moving that in. So now we need to differentiate that the credentials are optional. Some URLs will have credentials, some won't, right? So we need to check. If it's not null, we use the credential parameter, right? And otherwise we just do it without. Okay, and obviously because we want this automated, if we use credential and don't populate the credential parameter, it'll pop up for us, so automation won't work. So we need to differentiate there. But that's it. Check URL doesn't know how to get credentials, doesn't know how to use credentials, it doesn't need to, right? It just passes it to invoke web request, right? And we'll see something important very shortly with credential handling. You know, where does that credential come from? How do we get that credential object into check URL cleanly, right? And I didn't like the original solution which had plain text passwords in the ini file. That's not nice, right? So again, very simple change, and we've got a whole new functionality. We just added that credential parameter, and we added a check for it. That's it. That's all the change we made is those two little parts, and now we have support for credentials. Okay. Next, we're going to add logging and alerting support, right? And a constant monitoring parameter, so we can run this over and over again. Okay. So let's close that down. Because in reality, well, we could have this run as a scheduled task, but it would be nice to have something just running in the background all the time. Let's open it up. Okay, so here I've done a rename, check URI, instead of check URL. And there's a reason for that. Everywhere else we use URI, including in the built-in invoke web request, the parameters URI. So I've just tried to use the same naming convention everywhere, so it's not, we're not flicking between URL and URI and things like that. Okay, but on top of check URI, which is basically just check URL renamed, we now have a new function called monitor HTTP applications. Okay, this has a monitor period. So how often will we repeat the checks? How many times will we retry if it fails? Do we want to send alerts or not? And where do we want to log to? Now, all of these parameters can be overridden, but I've given defaults for each of them as well, right? So it's really easy to call this with no parameters and everything will just work. Okay. So this runs while true. This will just keep running till it's killed. Okay. This is something, you know, when a monitoring server booted up, you can have a scheduled task to call this on startup, and then it will just run. Okay. For each app in HTTP applications. So rather than have this complicated INI file, right, all the way down here, I have a messy little array that has PS custom objects for each check I want to do. Right? It's as easy to read and configure as the INI content, right? But I don't have to worry about import export. You know, maybe I want to put this out in its own script or module and then import it in here. But for now, I've just left it down the bottom, right? These kind of messy things we want to hide away from our core functionality, right? But this is a pretty simple piece of information we're trying to store, and I'm not really sure we need to, you know, export it out and re-import it in. It's just as easy to add a new line to this array as it is to go in and modify your ini file, right? And we don't need that get ini content. That, I think, is a good adapter if you've got existing solutions that must use the ini format and you're trying to integrate that. The get ini content module is a great tool for that, but we don't need to introduce that unnecessarily, right? So back up in our monitor HTTP applications, we're going to pull out the URI, the username. Now I've got a password file, not a password. Right? I've got a file where I store in an encrypted, secure format my passwords. Okay, so I'm not storing plain text. It's a much more secure solution than the original. And the check string. Right? Then we're looking if we need a username and password, right? And this is where I talked about how do we get credentials? How do we get credentials to check URI? So we build a credential object, right? We have built a convert to credentials function to do that, so we don't have all that mess up here. We give it the username and the password file, and we will get a PS credential object back that we can then pass to check URI. Okay. Now, if we scroll through here, there is no convert to credentials. Right? It has nothing to do with URL monitoring. Okay, so I've made another module for that. It makes sense to have that nice and clean, convert to credentials, and export password to text. Okay, this is how I can build my password files. Okay, so I create a credential object, pass it into here with a path to save it to. It'll extract the password, convert it from a secure string object into text, and save it into the file. Right? And this just does the opposite. It gets the content from the password file, converts to a secure string, and then it builds a credential object. And all the messy .NET stuff is hidden away in these modules. So now my URL monitor doesn't have to worry about it. And if I'm working with credentials anywhere else in my script library, I can save my passwords in that format and pass credentials automatically to my other functions. Right? So this is a much more reusable way than just doing, I could do that all in monitor HTTP applications, but again, it would be doing more than one thing. The only thing it should be doing is monitoring my applications. It shouldn't be converting my credentials. It shouldn't be saving things to file. It shouldn't know about those things. And actually, this is something you'll see that I change in the next iteration. So here I've got my retries, my alerts, my logs, and I've got that repeated here in URI, retries, alert, and logging. I'm just passing that through, right? And then I sleep for the monitor period once I've checked them all. Okay, very simple. Check URI is a bit more complicated now, a bit messier, right? I've got a failed equals true and count equals 0, and as long as failed is true and the count is less than the retries, I'll keep invoking the web request, right? If I fall out of that loop, right, and I will also log it, okay? If the logging equals false, I'll just push out the result, or if logging's true, instead of pushing it out to the screen, I'll log it, right, and append. And then basically I'm checking if it's not a 200 OK response code, failed goes to false. Sorry, if it is a 200 OK, failed goes to false, then I'll break out of the loop. Otherwise, I count up until I hit my retries. Okay. Then, if the response code is not OK after all my retries and alerting is true, okay, I send an email. This, you'll see, this is not good. Right? There's a lot of stuff going on here. I'm checking the URL. I'm logging. I'm also alerting. I got a, this is starting to get into messiness here, right? This is starting to get into different tasks being done by one function and different levels of abstraction. But one thing you can see here is convert to HTML heading and convert to HTML table. These come directly from my system information module, right, that I did last time. So already, from just doing 2 presentations to this group, I've got a number of modules that I can reuse. And instead of having it in sysinfo where I had it originally, I've brought it out into a format HTML module, right, where I've got, sorry, let me open that properly in ISE. Where I now have, I can get a standard HTML style that can fit here. So all my HTML reports and emails will have the same style. I can convert to a table, right, nice and cleanly with the fragment, so I don't get whole HTML pages, which is really messy. And when you're trying to accumulate different pieces of information into one HTML file, is really messy. Convert to a heading of various sizes, which I built before, right? I'm reusing them to build my HTML email alert. Okay, and send email. The built-in command is send mail message, but there's a lot of parameters that are needed there. If we look at here, there's a whole bunch of stuff going on. We've got variables up here for the server, send as, and the alert. Here's send mail message. We got from SMTP server to subject. What if we want to CC or BCC someone in? We can't. Body is HTML switch. We're building all of the HTML from scratch, right? There's a whole bunch of mess here just to send an email. Okay. Here we just have, here's the subject, here's the body, and we're building the body here using those HTML commandlets. But even this is too much, right? If we take a quick look at send email, again, split out to a module. Now, anytime I want to send an email from any one of my modules or scripts, I've got a nice send email. All it does is take the subject, the body, and an optional attachment. Okay? It goes and gets all my email parameters using get mail parameters, and then it sends a message. That's it. Get mail parameters here takes the subject and the body, right? And all of these things, default recipients, default system email, all of that I have again in some custom objects, right? So I can override them if I want, okay, but it's much easier now. Any script, is going to go to this email address. This might be a administrator distribution list. Okay, if I want CCs and BCCs, I can build them in. Okay, I have a system email that I send from, and I have a default mail server and credentials to use. And again, here's my password file. I'm already reusing my convert to credentials commandlet that I built, right? Because I need credentials again. I need a credential object. I don't want to store my stuff in plain text. So you can see very quickly, if you have good structures and you have good modules, you can start to reuse very, very quickly. You don't need to wait for a year until you've got 150 scripts to have reusable code. Within solving two problems, getting system information and checking URLs, I've got a nice library of general utilities to send emails, write HTML reports, get credentials, right, in a secure manner. So again, all of this mess of building the parameters for send mail message, right, this built-in commandlet, send email doesn't need to know about it. It all comes in this nice blob array from get mail parameters, and all of that noise, all of that mess, right, is pushed down into here. Okay, probably I could split this out and make this better again, right, but the main function at the moment is the URL monitor. But that's a great, send email would be a great one to revisit later to improve. So I'm not really happy, as I mentioned, that all of this stuff is in check URI. It seems to be doing too many things now. I've got a lot of the parameters in monitor HTTP applications that are just being passed through, and I might want to use check URI somewhere else, but not for monitoring. So I don't want retries, I don't want alerts, I don't want logs. I just want to check a URI. So I have one final iteration here where I've restructured it in a way that I think is slightly better. So let's close this down again. And open the last version of URL Monitor. All right. So here's Monitor HTTP applications, still the same parameters, but check URI, I've re-simplified it, right? It just takes the URI, optional credentials, and optional check string, right? And it does what it's meant to do, which is check a URI. And the logging and alerting, I've moved into monitor HTTP applications, because that's really what the monitor function should be doing. It should be using check URI to check it, and then doing the logging and alerting, which is part of the monitoring responsibility. Okay. Out file, I'm just doing a straight out file for logging, but I think there's a good candidate for some standard logging function there that will give me the standard format I want. So I'd call write to log file, right? And that would make sure that all of my log files had the same format. So if I'm then writing other scripts to pass my own custom log files and build reports, they all make sense, right? Monitor is doing the retry repeat, right? And monitor is sending the URL alert. And here even I haven't called send email. I've called send URL alert, which is just a little wrapper for it. Right, so send email is very generic. Send URL alert, right, still builds my body for me, okay? But I have a hard-coded subject alert, failed HTTP application, right? I have a hard-coded heading, alert, the following application has failed. These are specific to my URL monitor. I don't want them in send email, but I can build a little wrapper here that gives me, again, a standard email alert, and my table data is the result object that is pushed out by check URI. I've also got a timestamp that's reusing my create creation stamp module, again from my earlier work with system information. So now I've got a nice clean capability, and if everything works properly, which there's nothing to say that it will. Okay, let's just make sure that it's loaded the right version. Okay, if I run my monitor HTTP applications, okay, that should just keep running basically till I interrupt it, and I should get a failed email very shortly because one of my URLs requires a username and password, which it doesn't have. Here we go. And here's my failed message. Okay. Okay, so here I've got a nice table, the URI, the response. Here we go. That's what I wanted. That's the message. Okay. Timestamp, the check string should find hello guest, right? And actually, we didn't even get to check the check string because the remote server returned a 401 unauthorized. Okay. So now let's kill that. Go and put in our credentials. Okay. Just properly string that. Let's repeat that with the right credentials. And we should also be able to see file being written. So here's my log output, right? Again, it's formatted just directly from the object, right? Here's all my failures, but if I go right to the bottom, here, I've got a successful match for hello guest, right? A 200 OK, and this was the latest one done. Okay, and I'm just doing some basic checks against Bing and Yahoo. Right. So the next thing I think would be to get a nice logging module written where I get a standard format, even something compatible with syslog would be great. Then you could start pushing it out to syslog systems as well, right? Rather than logging locally. So if you get a nice standard syslog format, you can integrate it with all your management solutions like SolarWinds or whatever you're using. Or I might even decide that I want to start logging directly to the system event log, right? Or both. I kill this so it stops. So you can see that there are a number of things that are really important about ending up in this type of scenario, right? And you're very welcome to disagree, but I think this is a much more reusable solution already. There's quite a lot of code that I'm reusing in multiple modules. It's nicely laid out. I'm breaking a ton of PowerShell style guide recommendations, which I know, but the main focus on here was more on code design than on style design, which is still important. For example, I use a lot of S's, which in PowerShell they don't like plurals, and I use a lot of capitals, like URI should be capital U, lower R, lower I, but just through some other things I do, that's not natural for me, and I need to go back and fix them over time, which I didn't have time to do. But I think that if you can think about those few key steps, like telling a story with your code, you should read it like a story. It should tell you what it's doing. You shouldn't need a lot of comments or even any comments, right? If you need to write a comment, then think about why you need to explain it. What could you do to improve it? Could you improve the name? Could you move that noisy, messy code down into its own function with a name that described what it was doing in a clearer way, right? I mean, check URI. It tells you exactly what it's going to do. It's going to invoke a web request, right, against a URI, and it's going to check it, right? And then it's going to give you a result. Okay. Get last error exception is going to get the last error exception. Get creation stamp, right, with the time switch is going to get a creation stamp. Get URI message is going to get the URI message. Right? These are self-explanatory. And then we do have some mess down here, but status code, I don't know that status code and URI response code are the same, but now that they're clearly together in a name with that function, I can take a pretty good guess that's what this is doing. Right? I don't know that status description and URI message are the same thing, but I can work that out. Okay. So I think in all of these scenarios, the more you can try and keep those key points in your head about keeping your functions to one specific task, keeping the level of abstraction at the same level, using descriptive names, right? All of these things help you end up in this type of solution and help you write reusable code and help you write supportable and maintainable code that's very easy to bring into future requirements and future applications. So I hope that's been useful, seeing a second application of those kind of points and those methodologies. I think it's something that we need to get better at, and most of the people I speak to that do PowerShell, they don't use it very often, so they do forget what their code does. They're system administrators, they're not developers, and neither am I. My background is all system administration and network administration. So it's not natural to think about some of these things in our day-to-day work, particularly in the past, but it's really important that we start to take these ideas from development mindsets and development practices, that we start to use source control, that we start to think about the long-term maintenance of our scripts and our code, because that's where our roles are shifting and that's where our value to the organization is shifting. So we need to be able to do this in order to just keep up, but also to get ahead and really add value to our teams and our organization. That send email module, that's now a utility that can be used across an entire organization. So you have a standard way of sending email, right, of sending alerts. A log module would be great to write so that my log files and your log files look the same, and someone can go write a parsing module that can parse every log file that every script writes in the whole organization. You can only do that through having clear and maintainable code that's flexible and reusable. So thanks for your time today, guys. And now, if anyone has any questions or any comments, really, let me know, and I'd be happy to take any questions. Oh, who's in Maui? Dylan. I thought the weather was good in Sydney, but it's still not Maui. Is anyone, can I ask, because I know, Paul, you said you do a bit of development, is anyone already using source control and things like Pesta in their PowerShell development, or are people still using fairly straightforward scripts and just sort of straight out of the box? What about you, Milton? We're the ones that are telling everyone to use Pesta. Are you using it yet?
Unfortunately, I want to, but I can't. Okay, because in work they all use TFS, so we just want to keep everything in one repository. So.
Okay, yeah, that makes it tricky. The other thing I've noticed with Pester, if you name by default, if you name it PSM1 as a module instead of as a script file, it errors. You need to make some modification for it to properly pick up that. Yeah. Okay, Dylan, starting use Pester with Test Kitchen for share. Okay, great. Okay, Perforce for... Yeah, so, Paul, Pester doesn't give you source control, but it gives you a test framework. Yeah, I can show you. We covered this in my last one. I didn't really go into today, but I can show you a Pester file. Nope. Here, here's one. Here. So, for example, describe get WMI code. So that's the name of a function I want to get. A description of what it should do. This is just basically text output. And then test. So when I call get WMI codes and I check the BIOS key, it should be win32_BIOS. Right? I mean, these were simple tests to sort of demonstrate to people how to get started.
Oh, do you like...
Not hiding. Hang on. Let me share my screen again. Sorry.
No problem.
Thank you.
Dylan was first.
Yeah. What do you mean you're not psychic and you can't just see it in your mind? Okay. So here, this is a Pester file for one of the other modules that when I was demonstrating this. So you have a describe block, and then it returns a hash array of WMI codes. So get WMI codes will give me that hash array. And if I'm just checking one key for that to make sure that it's win32_BIOS, right? It's not a very comprehensive test. The test coverage is pretty weak in this, but it was more to show people what it does, right? So yeah, so this is a PowerShell module, and it's designed to test PowerShell scripts and give you some test-driven development framework to get started in. So it's definitely worth checking out. Pester I don't believe Pester is currently integrated with any continuous push out, but between DSC and Pester, you could probably build a fairly nice solution, because DSC, you could use DSC to push out your code, right, and update your code. It does a lot of other stuff, but you could definitely use it to push out updated code that had been tested and validated using Pester, and push that out to your application servers if you were doing PowerShell development in that way. What's the rule of thumb? Okay, that's a good question. So Paul's question is, what's the usual rule of thumb when deciding for a function to be in a module or a script? If you're, I mean, Milton, please add your thoughts on this, but my belief is that all of your functions should go into modules. Scripts should call functions to do a specific task, right?
Yeah.
So you combine function calls to achieve a task, and then that script might be called, for example, by a scheduled task or something else. But if you're writing a function, it should be in a module, because then it's preloaded into the system and it's callable from all your scripts. So, for example, with my system info that I did last time, that's all in modules now, right? And the original script would build a HTML report of all of the basically hardware and installed applications and processes of a particular machine. My modules don't do that. Nothing actually runs them. So my script would call the function to gather that, right? So functions should always be in modules, and scripts then call those functions to basically activate them, right? To initiate them and make them run. That's how I see it. I don't know, Milton, have you got any thoughts on that?
Well, I mean, my thoughts is similar to like web development or Windows development in C# or .NET. So it's something like your web front end, ASPX pages calling your individual class or different layer, like your business model layer, your data layer, so different type of layers, so that it makes your code much neater. You change any of the layer doesn't mean that you need to republish everything else, something like that.
Yeah, correct. Yeah. No, there's not. There's nothing in PowerShell, but that's where you could have a script repository you could pull from or something. If you wanted to stay inside of PowerShell, DSE is the only thing that can really push down, offer a push-pull model. But definitely, through source control and things like that, you can have a master repository that you can be pulling from to have that continuous integration and standardization across it. Milton, do you use anything particular? I mean, there's nothing different about PowerShell versus other code. I think, just whatever solution you're using to do that, you could use for your PowerShell scripts as well.
No.
Yeah. It would be the same type of...
We are still very manual about doing that, so... Okay.
Oh, okay, so you still have manual. Okay. Yeah, but there's nothing specific about PowerShell code. Whatever you're using to push out your other code, you could do the same with PowerShell. Yeah. Even if it's just something like a scheduled pull from a master repository, right? It's, yeah. Can see Paul's typing a message.
Yeah.
Just wait. Okay. Oh, you mean what I showed today?
How do you extract? What do you mean that? How do you extract the?
Oh, okay. Yeah, no problem. I can. Let me go back into the. Okay. So I wrote two functions. I just called it custom credentials, which is a bit clumsy, but I was a bit worried about junking up the namespace. I need to go find a good name for this, but basically, I've got a convert to credentials and an export password to text. So this function takes. Let me just bring this up. So export to password text. What that does, if I just get a credential, okay. Okay, so if I get that credential object, right? It's there, okay, username, and I have a secure string object, right, for my password. So what export password to text does is save this password, convert it from a secure string object to basically a secure hash that I can save into a text file. So this line here is just taking the credential password, right, putting it into convert from secure string, right, which outputs this big, it dumps this, right, and then I'm saving that in a file. Okay, then convert to credentials is reversing that. So I give it a username and a password file that has this blob in it, and it will output this credential object for me that I can then use. So these are just mirror images of each other. Right, so it gets the content from the password file, converts it back to a secure string object, and then it combines the username I gave it with that secure string to build a PS credential object for me and returns it. So that way I can securely store my passwords on file. So this is different. This is not the account that the script is being run as. This is modules where I need to provide a credential, like I'm logging into the website. So it's different from the security context of the script itself. This is actually to pass credentials to certain commandlets, like I need to authenticate, send mail needs to authenticate against the SMTP server. So it's a slightly different use case than the security context of the script that's running, right? Yeah. So it's a way, there's a lot of things like logging into a web application. You might want to do it at check against Exchange or something, right? You want to log into a mailbox. When you send, you've got to log into the SMTP server. This is where this comes into play.
Anyone who has access to the script could easily grab it and run it, but there's no way you can stop the person from running it.
Yeah,
If it's a successful run or not. Yeah.
Yeah, correct. The only way to do that would be to put general security restrictions on the file itself, like through your general Windows permissions.
Or
right?
probably if
they didn't have the permission to execute, it should be possible. But yeah, restrict access just through general Windows rights.
So Dylan has a question on the tester resource.
Yeah, is there a pester resource on the web that different test modules are listed for examples to use? I don't. Pester's quite new, Dylan. It's still very much. I would say, I don't know, Milton. It's kind of like beta, right? We had the creator of Pester on a couple of months back, talking about it. It's very much. It's probably one step beyond proof of concept, I'd say, right?
It's still very young. I could say it's still
very young, but that is a great sort of community project to start building up tests around the standard commandlets and uses to make sure that you're getting the right thing out of it. But I think where it really comes into play is when you're building your own custom stuff. You can sort of trust the built-in commandlets to a certain extent, which I know is a really bad assumption to make because they have their own bugs and problems. But yeah, there's nothing as comprehensive as what exists for some of the other testing suites out there because it just hasn't been around long enough. And I think the idea of test-driven development in PowerShell itself is very new. Most people in PowerShell aren't developers, they're sysadmins, and thinking about that, and that's what we're trying to promote is getting sysadmins thinking about testing suites, writing these libraries of testing suites and using source control to improve what they do.
But do not worry, we'll shout out to the creator of Pester and then say, someone...
Yeah, we'll say, oi, what are you doing? Get it sorted.
Yeah.
Yeah. Paul, sorry, I just wanted to check, did I explain about the credentials properly? Does that make sense? Okay, great. By the way, this whole thing, password get, like how to do this, I just pulled off the PowerShell blog somewhere. It was on there. I just put it into two commandlets, basically. So I completely ripped that off the PowerShell team.
So starting off should be a good practice to start writing a function in script plus creating a test to work out your code.
Definitely, Dylan. Even not just starting out. I mean, I didn't focus on it today because I had a week to build this presentation because the scheduled presenter couldn't make it, and I was at a number of trade shows and projects this week, so I shortcut that bit out, but my last presentation definitely had pester tests around all the changes I made. Particularly, when I do that final change from check URI and move that functionality into monitor HTTP applications, how do you make sure nothing broke? How do you make sure when you move something out into its own function, maybe parameterize it or add a new capability, how do you make sure you didn't break old functionality, right? The only way to be confident about that is to have a testing suite behind that where you can run that and ensure that no existing tests broke and all your new tests pass, right? So it's something that it's not specific to PowerShell, it's just source control and defining unit tests is just really critical to writing any kind of code with confidence beyond, just simple one-liners. Once you start getting into complicated functionality, and it gives you that confidence to go make a big change and just see what happened because you can roll it back, and you can go on to the next stage confident that what you just did hasn't broken anything.
So pause a question in terms of the required particular module. So you could start to import all the module first, and then if there's a problem importing, then you will throw an error. So before you execute the main part of the script. What do you think, Ben?
Yeah, there are ways to do that in PowerShell. There are ways to ensure things like minimum version. So requires PowerShell 3, for example, right? And requires certain prerequisites. That's definitely.
What about customized module? Let's say I write a couple of other modules, then I have my main script calling all these modules. So how do I ensure that all these modules exist in the folder before the main part of the script could run?
I'm pretty sure that's in the latest versions. I just can't think of the command. I thought there was. Oh, sorry, I'd have to check, but I'm pretty sure that's in. It wasn't before, but I'm pretty sure that you can essentially do require statements. Yeah, I'm pretty sure that's in the newer versions of PowerShell, already built in. Just need to, I can't think off the top of my head.
Okay, I found this link.
Oh, great.
Yep. So this is in PowerShell 4.0.
Yeah.
Yeah. So if you open up the link, it just tell you that there's certain syntax that control the version, the PS mapping, the module, and it requires let's say it requires elevated privilege like front-end administrator.
Yeah, there about requires. Yeah. And here's the syntax.
Yep.
Yeah, nice. I thought so. I'm pretty sure. Yeah, somebody
must have needed it.
Yeah, I'm pretty sure. I think it was Ravi when Ravi did his "What's New in PowerShell 4." Like, I don't know, like a while ago now. I'm pretty sure that was one of the things he highlighted. Yeah, which is good. I mean, that's good functionality that, again, is just sort of standard across languages. And that's where you can see, VB script and stuff like that. It really was limited to scripting. PowerShell is much closer to a full, abstract programming language, closer to something like Python. I would say it's heading that way anyway. It's definitely not as mature as Python, but it's getting there.
Yep.
Okay, any other questions for today? That was good, actually. I'm glad. I hope everybody got something out of it.
Question, yeah.
Lots of good conversation, which is good. So it couldn't have been too boring. I think that there's a few developers on this call. I think you guys are used to these kind of ideas and concepts, but for a lot of people out there in the PowerShell community, these are new ways of thinking beyond just scripts. So. Certainly, it's been a while for me. A lot of the last year or so is when I've really started to focus on these kind of things.
Okay, looks like there's no more questions, but you will find more interesting speaking session by Ben in CTU this coming Saturday, 15th of November. So if you have not registered, please kindly register and be present there so that you could hear more awesome presentation by Ben and other MPPs.
Yeah, and also this coming Friday, I think on the 12th of November, if you're in Sydney, there's the relaunch of the Sydney UC User Group by Justin Morris. So if anyone out there's listening from Sydney, definitely check that out.
Will Justin Morris have that online?
I don't know. I'll ask him. I'll get him to tweet it out.
Yeah, so if we can, then probably on our side we could tweet it out and then get our guys to join.
Yeah. I'll speak to him and get him to tweet it out. And all right, we'll see CJ at CTU. Great. All right, guys, have a great weekend, and thanks again for your time. And talk to you next time.
Okay, goodbye.